In number 11, we have a related rate problem. All right, it says a volume is changing over time, and the volume is given by this little equation over here, where x and y are also changing with time. If dv dt is equal to 5 and x is equal to 2y, find dy dt when y is equal to 4. Well, what we want to do is get an expression that contains dv dt and dy dt, so basically we want to differentiate this, but this with respect to t. Okay, we always for related rate problems, we differentiate with respect to t. But this equation has too many variables. On the right-hand side, we have a total of 3 variables, v, x, and y, so we want to eliminate one. So the first step is eliminate. All right, so we want to eliminate one variable in the equation v equals 3x y squared. And we're going to use this equation to eliminate, we might as well eliminate, well, it's best to eliminate x because we want to find dy dt. So we want y to stay in our equation, so let's eliminate x. X is equal to 2y. So right here we're going to replace x with 2y. So we have the volume is equal to 3 times 2y times y squared, which is 6y cubed. All right, now let's differentiate step. Let's differentiate this volume, v equals 6y cubed, with respect to t. So here we have dv dt is equal to 6 times 3, that's 18y squared, times dy dt. All right, and now we're up to the substitute step, where we're substituting in values into the derivative. So we're substituting in dv dt is equal to 5. We'll put a 5 over here. And we want to find dy dt when y is equal to 4, so we'll put a 4 here for y squared. All right, so we have 5 is equal to 18, and that would be 4 squared dy dt. And we'll solve, just divide by 18 times 4 squared. So we have dy dt is equal to 5 divided by 18 times 4 squared. So that's equal to 5 divided by 18 times 16. That's 288. In number 12, in part A, we want to find the average value of the function, of this function on the interval 1, 3. So let's just remember the formula. The average of f of x on AB is equal to 1 over b minus a times the integral from a to b f of x dx. All right, so here we have, in our case, the interval is 1, 3, so we have 1 over 3 minus 1. We're integrating from 1 to 3, 3x squared plus 2 dx. All right, so this is just 1/2. And let's evaluate this integral. Do the power rule. So that's 3x cubed over 3. All right, so that would just be x cubed plus 2x. And we're going to evaluate between 1 and 3. That means we're going to substitute in 3 first. That would be 27 plus 2 times 3 plus 6 minus, now we're substituting in 1. That would be 1 plus 2. We're going to multiply all that by 1/2. So this is 1/2 times 30, or 15 for the average value of the function on 1/3. Now in part B, we want to find the average rate of change of the function, and that would be the slope of the secant line from x equal 1 to x equal 3. So the average rate of change of f of x on 1/3, that's equal to f of 3 minus f of 1 divided by 3 minus 1. So that's the slope of the secant line. So let's just do f of 3. F of 3 is equal to 3 times 3 squared. 3 times 9 plus 2. That's 29. And f of 1, just substituting into here, 3 plus 2 is 5. Okay, so back to this expression. Let's just go back here. That's f of 3, 29, minus 5 over 3 minus 1. That's 24 divided by 2, or 12 for the average rate of change. In number 13a, we're applying the second part of the fundamental theorem of calculus. And let's see, it says that this derivative is just equal to this function with x substituted in, so that would just be cosine x. Okay, let's see what we have here in part B. So that was part A. That was A. Let's look at part B. Here we have this derivative. Well, again, we're going to substitute in x for t. And we're going to, since we don't have x here, but we have x squared, we're going to multiply by the derivative. So that would be, that's a little chain rule. So that would be 2x. All right, so the derivative is equal to the square root of x to the 6 plus 1. And I'll put the 2x in front here.